Okay, so hi guys. In this video, what I want to go over is, um, the definition of, I don't know if I went over the definition of parallel lines. Um, Let me see, one second. Okay, so, um, I want to go over, like, the definition of perpendicular lines. So in my shorts video, or like if you go to my shorts on the on my channel, I did go over very briefly. I believe I went over, hold on, so I believe I went over parallel and perpendicular lines. I did forget to go over horizontal lines. I also went over vertical lines in algebra. I'm going to quickly go over that. Horizontal lines are just, they're of the form y equals c, where c is any number. So like, I don't know, so let me kind of just, okay, so just for the sake of it, I'm going to go over both. Horizontal line means that it's of the form y equals c. So when we have just y equals on its own, it's literally just a horizontal line that goes through the y-axis, and is of the form y equals c, where c is any number. Now, a vertical line is of the form x equals b, where b is any number, and it goes through the x-axis. So, I mean, honestly, so when they ask for slope in this, you have to understand that, like, we have to know that basically when it's of the form x equals b, where b is any number, the slope is undefined because, let's see, because it's rising, but it's not running. You see, so basically, to explain this more clearly, 1, 2, 3, but it's not running. So it's like saying, you know, the slope is 3, but it's not running anywhere, so it's 0. So that's undefined, right? So we have to remember that for vertical lines like that, the slope is undefined. For horizontal lines, the slope is 0 because it's not rising. This one is not rising, but it is running, right? So it's rising at 0, and then it runs 1, 2, 3, 4, however many times. So it's like 0 over 3, for example, and that's still a slope of 0. That's the difference between vertical and horizontal lines. Now, we notice that they form a 90-degree angle. So they're perpendicular to each other. So vertical and horizontal lines are perpendicular to each other. That's something that I really want to make very clear. And then let's see what else. And this is an example of, I don't know if I already went over this, but this is an example where the two lines that intersect have a 90-degree angle because of, because basically because of this, right? So I'm gonna go over an example that, let's see, one second. Okay, so let's look at this one, and the reason why I'm starting with perpendicular lines is because they're actually the harder ones than parallel. Perpendicular, I feel like they're they can get very confused very easily. So I want to go over perpendicular lines first, before anything. And maybe in a separate video, I will go over standard form of an equation. I'm not going to really go over standard form in this video. But yeah. So, okay, so it says, give the equation of the line in slope-intercept form that goes through negative 3, 6, and is perpendicular to y equals 3x plus 7. So the first thing that you're going to do is you need to know what it means when it says perpendicular, right? So perpendicular simply means, it basically means, like I said up here, there's a, so if you haven't seen this, or if I haven't shown this in the video, I do apologize, but basically there are two lines that intersect and form a 90-degree angle, and in terms of slope, that means that the slope is given of the form, so if it's given of the form a over b, then the slope that is perpendicular to that will be negative b over a. So our slope, in this case, if we look at this equation, right, we have y equals 3x plus 7, right? And 3 is my slope, right? Because remember, y equals mx plus b. So I know my slope. My slope is 3. So my slope is 3. However, it says perpendicular to this. So, like I said, if you have a slope that is of the form a over b, then the perpendicular slope will be negative b over a, okay? So right now my slope is, let's just say 3 over 1, right? And so that means that my perpendicular slope will be negative 1 over 3. Okay, so we know the perpendicular slope now, but let's look at this other part. It says goes through negative 3 comma 6. Okay, so using this new slope, we can use the form, the point slope form, y minus, we'll do this, y1 equals, and like I said, I'm going to put m as, I'll put m as green. Do this. M times x minus, so x minus x1, right? Now, excuse me. So, obviously we have a point here. We have x1 and we have y1. So this is x1 and this is y1, right? Okay. So, looking at this, you can say y minus 6, right? So y minus 6 is equal to, and we're using our new perpendicular slope because it wants the slope perpendicular. So we said that the perpendicular slope is negative 1/3. It's right here, right? So we're going to say negative 1/3 times x minus, and then our x1 is negative 3. So we're going to put parentheses negative 3 like this, okay? So then y minus 6 equals negative 1/3 times the quantity x plus 3. Okay, we're almost done. It says slope intercept form. This is point slope form. It's not slope intercept form. So all you really have to do is just distribute and say negative 1/3 x, I think it'll be minus 1, and then add 6 to both sides, right? and you get y equals negative 1/3 x plus 5. Okay, so this will be our answer. Now, that is for perpendicular, okay? Let's say we have a question in where it gives us a parallel slope. So give me 1 second. Okay, guys, so now we're gonna go over parallel. So I'm doing both of these like in one video. So yeah, so anyways, it says find the equation of the line that is parallel to the equation y equals negative 2/3 x minus 3 and goes through negative 3 comma negative 1. Okay, so the one thing to know about parallel is it's literally the easiest one. So here, what I mean by parallel is it literally has the same slope. That's all you need to know. It's really not that hard. It's the same slope. It just goes through a different point. Okay, so here in this equation, this is in slope-intercept, right? And again, I'm going to write it in slope-intercept form, so I forgot to add that. Okay, so in slope-intercept form, and that is parallel to the equation y equals negative 2/3 x minus 3 and goes through negative 3, negative 1. So our slope is negative 2/3, right? Because of slope-intercept form. Remember, like I said, slope-intercept form is y equals mx plus b. This is my m, okay? Now, I know that I'm going to have, because they're parallel, I'm going to have the same slope. So in my equation, m will be negative 2/3 because, like I said, parallel, just remember, parallel means the same slope. It's literally the same slope. And then, but it says it goes through negative 3, negative 1. So don't confuse yourself and think it's this line because it's not. I've done that before, and yeah, no, it's not. So what we need to do is, because we have a slope and we also have 2 points, or not 2 points, like basically an x and a y coordinate, we can use those to find the equation of the line that is parallel to this equation. Okay, so basically you're gonna do, so let this be x1 and then let this be y1. Okay, so we're gonna say y minus y1 equals, and we're gonna say m times x minus x1. Okay, so x1 is negative 3, y1 is negative 1, and then my m, like I said, is negative 2/3. So I'm going to plug that in. So I have y minus negative 1 equals negative 2/3 times x minus negative 3. Okay. Just like this. Okay, so we have y minus negative 1, so that's y plus 1. And then negative 2/3 times x minus negative 3. I'm going to say negative 2/3 times x plus 3. Okay, now, what you're going to do here is you're going to go ahead and say, okay, so it's like we've been doing all the time. So when you're doing it in point slope form, or when you have it in point slope form, you're going to convert that to slope intercept. So how do you do that? Basically, you're going to go ahead and distribute, and you have y plus 1 equals negative 2/3 x, and then it'll be minus 2. And so what's left? All you have to do is subtract 1 on both sides, okay? And this will give you y equals negative 2/3 x minus 3. And this is the line that is parallel, or I'm sorry, well, yeah, is it? Right, parallel to the equation y equals negative 2/3 x minus 3, and goes through negative 3, negative 1. So the last thing I'm going to do, guys, is I'm going to show you graphically how that looks, so that you guys can understand visually what I'm talking about. So give me 1 second. Okay, guys, so here I am on Desmos. So what I'm going to do, I'm going to look at the first one to see if I did it correctly. So it says, give the equation of a line and points in slope-intercept form that goes through negative 3, 6. So I'm going to go ahead and plot that. So negative 3, 6. Okay. And I'm going to go ahead and label it as well so that you guys can see it. And let me kind of just do like that. Okay. And then it says is perpendicular to y equals 3x plus 7. So let me graph y equals 3x plus 7, okay? And then, so let me go ahead and, can I label it? I don't know if I can label it. Okay. Okay, well, I guess I can't label it, but this is 3x plus 7. The blue line is 3x plus 7. And then the next thing it says, so then it's perpendicular, right? So then I'm going to go ahead and plot, or not plot, graph this line. So negative 1/3 x plus 5. So let me go ahead and plot it. So negative 1/3 x plus 5. Okay? And you see, guys, that this literally looks like a 90-degree angle. It literally looks like it forms a 90-degree angle between, so it goes like this, right? If you guys can't see that, it goes like that. And then, so that is, so obviously that one, that's how you know you did it correctly, because it should form, there should be a 90-degree angle between the two lines, okay? And then, let's look at the other one, just to make sure. So, another thing about parallel lines, I forgot to do this really quickly. Okay, so, parallel lines are lines that never touch. They don't intersect. So, basically, they have the same slope. So, they just don't intersect. So let me go on Desmos really quickly here, and I'm going to show you guys exactly what I mean. So let's say we have this line of this form, so y equals mx plus b, and then let's say we have so like, for example, if m equals 1, it's gonna be the same slope, it's just gonna be a different y-intercept. So for example, if I have y equals 2x minus 1, and I have y equals 2x plus 4, these two lines literally have the same slope. They're parallel to each other, so they have the same slope. So that is the definition of a parallel, of two parallel lines. So let me see. I think I went over. Yes, I did go over that. So that's how it looks graphically, right? So so yeah, that's the only thing that I did want to go over in this video, guys. I feel like I did go over most of the things that I wanted to go over, and so yeah, so if anybody has any questions whatsoever over this topic, you can let me know in the comments down below. And yeah, like I said, I went over horizontal lines, vertical lines, and then perpendicular lines, which form a 90-degree angle, and then parallel lines, which just, they have the same slope, but they don't have the same y-intercept. So yeah, with that being said, guys, thank you so much for watching, and please like, comment, and or subscribe, and I will see you guys in the next video. Bye, guys.